Respected Principal, dear professors and all other organizers, thank you for the chance having given to me. In this small lecture, just I am going to throw some light on the nanomaterials and its applications. Let us see the slides one by one. The first numerical calculator was invented in the year 1946. It was occupied almost a room, but later on it has been reduced in size manifold. Finally, we obtained a handset that we call it as smartphone. It occupies everywhere, even those smaller guys. They are also using this. Without this smartphone nowadays, nobody cannot work. Even living is also problematic nowadays. This is how it occupies. Similarly, the smartphone, it also doing lot of works. It has several sensors, so a small device inbuilt to the device. It can do a lot. It can sense so many things in our body, pressure, and all those things. Even it can back up us depending on our activities. It can suggest us. This is how the devices are improved nowadays. And also mainly nowadays all the people we want to have a miniature device. Everything. That's what the mobile phone, the smartphone has become very small. In all those cases, suppose you see in case of robo or any satellite, everything, there is a small chip. It can control the whole satellite controls. Like this, we can have a robo, and also we can inject some robotic, that is molecular robos. It can do some functions in our body, so that this is how we improve. And also our aim, future aim, globally the researchers, what they are doing is they want to reduce the gap between the man and the machine. This is what we are going to give intelligence. That's what we call it as artificial intelligence. This is how the scientific world is developing. It is wonder how we have achieved all those things. The very smaller devices having so much of power and density. Even in this slide you see previously we used some gramophone disc. It has some power, it has a storage capacity very low, but later on it was reduced in size, but at the same time the density, storage density was improved. Now we are having a flash drives offers terabytes of capacities. How these are all achieved? This is a wonder. All these benefits or improvements are only due to the materials what we are using. Those materials we call the smart materials. That's what all the devices are. We calling them as smart devices. But in that case, the smart or intelligent materials are the materials that produce stimuli or signal depending upon the environment, ambient conditions. Therefore, if there is any change, like physical, chemical, or any other properties change, it can easily sense and convert into our useful output. This is only because of the materials what we are using. In case of materials, mainly we are considering only solids. The solids are all in three parts, three kinds. That is conductors, insulators, and the semiconductors. In case of conductors, you all may be knowing that it conducts well because the energy band gap is very less. Practically there is no gap. That's why it conducts reasonably in a good level. The other one is insulator. It won't conduct. Its conductivity is totally zero. This is because of very high band gap. Otherwise, there is another material in between these two. That's what we call it as semi, because it is in between. It is neither a conductor nor an insulator. It's a band that is in between. That's what we call it as as a semiconductor. Though it is a semi, it is mainly used in all other cases because of its property. In case of the solid materials, or even if it is semiconductor, they can be classified depending upon the structure or size. Mainly used to say nanostructured materials or nanomaterials, or even as smart materials. The materials in the size between 1 to 100 nanometer scale are called as nanostructures. And also depending upon the quantum confinement, they can also be called as quantum structures. If we consider a bulk nanomaterial, that is, it has some size. Those materials we call it as nanomaterials. In this case, it has, if there is a single electron, this electron has a 3 degrees of freedom. That is, the electron can move any direction, x, y, z, any direction. That is, its confinement, degrees of confinement is 0. This is what normal nanomaterial. Other than this, there are quantum well, quantum wire, quantum dot, and others. In case of quantum well, it is a 2-dimensional material. It is a nano layers. In this case, the electron can move only freely in 2 directions. That's what we call as 2 degrees of freedom. Therefore, degrees of confinement is only 1. If we consider this a person, he can move only up and down, or front and back. He cannot move in another third direction. This is what confinement. It is in case of quantum well. Like this, there is also another one. It is a quantum wire. The quantum wire is nanorod, nanotube, and others. In this case, if there is any electron, it can move only one direction, but it cannot move in other 2 directions. That's what is confinement is 2. If we consider a person in a tube, this like person, he cannot move other 2 directions. He can move only one direction. Similarly, if you see this person, he cannot move anywhere. He is trapped in a cage. This is what, if a material, if it is very small, that is we call it as quantum dot, or 0 degree. Its degrees of freedom is 0, degrees of confinement is 3. That is, the electron cannot move anywhere or any directions. Just you think of it. If you trap a person in a cage like this, you think of his mind like this. The electron in the quantum dot can behave different from other bulk materials. So the quantum dots are very interesting and innovative materials. It is playing major role in all the smarter devices. If we see the properties, here let us see some of the properties of the quantum dots. Quantum dots, these are all very smaller in dimension. It is a billionth of a meter in size. Quantum dots can have a properties combined between those bulk semiconductors and atoms. It has both the properties, atoms properties and material semiconductor properties. It can strongly absorb visible light and increase solar energy conversion. In case of solar cell, it gives advantage. It is advantageous one if we are going to use quantum dot. A quantum dot has a discrete quantized energy states. Not it has a discrete, not as only 1 or 2 levels. There are continuous discrete energy states. Due to the quantum confinement effect, optical properties and the backup of the quantum dot can be adjusted by changing the size of the QDs. Therefore, depending on the size, there is only one material, that would be zinc oxide. If you are having quantum dot, the quantum dot's size, depending on the size, its optical properties and other properties are changing, are varying. Therefore, by adjusting the particle size, we can able to have our desired properties like any other. Therefore, the properties of the quantum dots can be easily tuned by changing the size. Compared to biological molecules, the quantum dots, nanomaterials, they are all very smaller, even compared to the molecular sizes. If we consider any virus, its size is around 100 nanometer, or therefore the nanomaterials are all lesser than this. So we can easily inject the nanomaterials into the human body, into the blood, wine, and all other things. So that it is also medically very useful, the nanomaterials. Here you may wonder why the nanomaterials are only behaving like this, showing high efficiency in all other activities. These are only because of when we reduce the size, its area, surface area is increased. So that if area increases means its activity, surrounding activity is more. For in all other sensor or any other devices, surfacial phenomena is taking major role. Therefore, its efficiency is automatically increased in case of nanomaterials. For example, if we consider these two trees, one tree is having less number of leaves but a large area, but other one is having very smaller leaves, but the number is very high. So you see here, this first tree only can have a more photosynthesis. It can have more yields. This is not only because of the surfacial area. If you see the this slide, here is a small soccer ball is divided into number of smaller balls. If you calculate the area, the this only can give more areas. The number of balls instead of single ball. Similarly, you see here in other pictures where the very bigger ball is divided into smaller balls, so that it gives large area. Even the solution or any chemicals can penetrate into the ball and it can absorb on the surface, so that its efficiency is automatically increased. This is what main advantages of nanomaterials. And also another interesting phenomena, if you are going to consider only nano size nanomaterials, for example, if we consider only the carbon can have a different phases in a nano. For example, you see here it can be graphite, diamond, buckyballs, and in carbon in nano size they are all in a different categories. Carbon nanotubes, CNT, graphene conductors, like this, and also we can have a nanofoam. Therefore, a single carbon, the carbon is not a very smaller material. It is going to play a major role in future for all other cases. But the carbon can be in different forms. If you are going to use it in nano size, nano dimension, it can play a major role in scientific world. So, because of these advantages, the nanomaterials are going to play a major role in all the fields. For example, in electronics like quantum computing, nano-electronic devices, semiconductor devices, like medical field. In medical, both diagnosis and therapeutic, for all the purpose it is used. Like this in case of energy. In energy, all kinds of energy, solar, thermal, or any kinds of energy conversion, we are using nanomaterials. Similarly, some sensors, gas sensor and others, and also for storage of energy. So nowadays there is a very interesting fuel is hydrogen, but hydrogen production, even the hydrogen can be produced from the water. For the production of hydrogen and the storage also, in future nanomaterials are going to play a major role. Like not only with this, in all other package materials and the construction materials also we are using nanomaterials. For example, you see here, if you are putting a nanomaterial coating, it can be rough whenever we want a rough or smooth. Depending upon the case, we can decide the size or nanomaterials. And also, depending upon the nanomaterials what we are coating on the window panes, it can either cool or heat the room depending upon the case. This is how we can design the materials depending upon our use if we are going to use nanomaterials. And also it is an interesting application. The nanomaterials can be used as a nano generators. For example, you see here, if you are going to use a zinc oxide as a piezoelectric material, the mechanical vibrations can be converted into energy. Similarly, you see here all other vibrations or ambient mechanical vibrations can be converted. You see here breath, blood flow, heart beating, wind, wave, body movements, traffic noises, airflow, all can be converted into energy. So therefore, since the device is very smaller, very miniature device, they can be inbuilt into the body or any other devices, so that it can be used in all other implantable devices, wireless sensors, nanorobots, nanosensors, MEMS, cell phones, laptops. In all other case, we can input a device. It itself can convert the ambient energy vibrations into energies. Therefore, we need not to replace the batteries. Therefore, it is a permanent device, can convert the atmospheric temperature or any other energy and can be used. This is only because of the nanomaterials. The nanomaterials are produced by the two techniques. One is top down, another one is bottom up approaches. In top down method, it is very rarely used because the bulk material is reduced into smaller size. Whereas in case of bottom up, it is interesting innovative method. Everywhere we are using to produce nano devices. It is from biological molecules to we can design some nanomaterials. That is, using the molecules we can fabricate electronic devices. Like this, if you are going to use biomolecules for a sensor or any electronic devices, we can call it as molecular machine. You see, our photoresponsive molecular machines have received a great deal of attention in the past decade. Their high sensitivity and fast response are the great interest for molecular devices increased. These are expected to find application in the field of molecular switches, memory and logic gates. These are mainly going to use in a future generation of computers like a quantum computer and others. Another one advantage because of the nanomaterials. Suppose if you are going to use some biomaterial, there we need not use electrons. Instead of electrons, we can use photons. If you are going to use photons, you may be knowing that its mass is very less, moreover its speed is very high. So the storage, that is photonic storage, the conductivity, everything is improved, so that in future we can use photons instead of electrons in all other fields like computer, calculator, everywhere. So that along with other improvements, the speed and everything can be improved because of the photons instead of electron. As I told earlier, if you are going to use molecules in electronics, totally its size and is improved, and also they can self assemble. We can use bottom up, and by using the molecules we can construct, we can fabricate inverters, NAND, NOR, adder, or any like these electronic devices. For conducting purpose, we can use CNT. By connecting molecules. Therefore, by using this, we can fabricate electronic devices like transistor, FET, and other electronic devices. So combinedly, we can have some device, sensor device also, even like a computing machines also using biomolecules. In that case, we will use only the photons instead of electrons. Here you see a single CNT is used to fabricate a FET. Here, by using this like a design, we can easily fabricate a very small, very nano transistor, that is a FET, so that it becomes very efficient and miniature device in future. If we consider a biosensor, it basically consists of bioreceptor, signal processor for converting electronic signal to desired signal and interface to display. But in all these cases, for all those cases, we can use nanomaterials. Nanomaterials are only used. Therefore, it is easy to fabricate any kind of sensor. As I told earlier, the nanomaterials are mainly used in case of energy sectors, energy materials, mainly in case of solar cells. There are different forms of solar cells. So far we are using only PN junction solar cell using silicon. But in future we are going to use different kinds of solar cells, infrared photovoltaic cells, multi-generation solar cells, quantum dot sensitized solar cells, rainbow solar cell, intermediate band gap solar cell, luminescent concentrators. Like this, there are so many things. Therefore, totally, if you are going to use nanomaterials and quantum dots, its efficiency still can be improved, because as I told you earlier, single photon can produce number of electrons. That is, the carrier can be multiplied if you are going to use nanomaterials. Moreover, depending upon the size, its efficiency, its absorption capacity is also varying. This is how nanomaterials are going to play a major role in case of energy. Therefore, mainly the nanomaterials are going to play a major role in the energy sector. In future, mainly we are going to use hydrogen as a fuel. For the production of hydrogen and the storage of hydrogen, the nanomaterials in the form of metal oxides are going to play a major role. And also here I want to introduce one of the company. It is a Bloom Energy company. They are mainly working on the hydrogen production and storage. Some generator, they are even like our batteries or generators, they are producing some generators. Each and every one we can have it only because of hydrogen energy they are using it. This is what the company, its company name is Bloom Energy. Its CEO is KR Sridhar. He is REC student, REC Trichy student. He is running a company in USA. Therefore, with this short introduction about the nanomaterials, I would like to thank the organizers and all others. Thank you very much for your patient hearing.